Welcome to 4-3 prime factorizations. We're going to learn today how to write the prime factorization of composite numbers, and we're also going to conquer the objective how to factor monomials. Before we begin, we'll review something. One is prime numbers and one is composite numbers. The definition says a prime number is a whole number that has exactly two factors, one in itself. There's a whole list of them. I recommend that you memorize them. But for right now, an example of a prime number would be something as simple as 19. 19 has no other numbers that we can divide it by. And so 1 and 19 are the only factors that it has. A composite number is the opposite of prime number. Composite number is a whole number that has more than two factors. 0 and 1 are neither prime nor composite. So it's a little something extra that you should remember. Some of the simple ones is something as 22. 22 does have 1 times itself. 1 times 22 is a factor. But we could also say 2 times 11 will also give me 22. So that's what makes it composite. It has other numbers that you can multiply together to equal 22 besides 1 in itself. On this slide, you see a chart. It has the whole numbers. It has the factors of whole numbers between 1 and 10, or I should say 0 and 9. In this case, the first set is prime numbers, 2, 3, 5, and 7. The next set is composite numbers, 4, 6, 8, and 9. And of course, as I said in the other slide, neither prime nor composite are 0 and 1. All right, so how come 2, 3, 5, and 7 are prime numbers? Because they only have two numbers or two factors, one in itself. Composite numbers such as 4 have 1, 2, and 4. So remember, 1 times 4 is 4 and 2 times 2 is 4. And notice we don't use the repeated number 2 twice. We only keep it once. So there you go, ladies and gentlemen. That is a quick chart from 0 to 9. And of course, numbers go to infinity, and I suggest that you start memorizing these for ease in later on in your algebra career. All right, in this slide we have two key terms, prime factorization and factorization or factor tree. When a composite number is expressed as the prime product of prime factors, it's called prime factorization of the number. One way to find prime factorization of a number is to use a factor tree. And you have an example of 48 made into a factor tree until we cannot go no more. So 48 is our composite number. We chose two factors, 8 times 6, and then we decided to break down 8 into 4 times 2, and then we finally ended up breaking 4 down to 2 times 2. Notice that these are prime. Go back into 6. We broke it down to two factors, 3 and 2, and those are prime numbers, so we stop. We'll continue on with more examples in further slides. Our final key term, factor. To factor a number means to write it as a product of its factors. A monomial can also be factored as a product of prime numbers and variables with no exponent greater than 1. Negative coefficients can be factored using -1 as a factor. Now we have all our key terms, and of course we'll have examples of each in our future slides. All right, our first problem is determine whether 19 is prime or composite. All right, in our previous lessons we used how to do divisibility rules, and in this case 19 we can sit there and say is in the ones digit is 2 even, and 1 plus 9 is 10. Is that divisible by 3? And then we could also bring out our calculator and plug in some other numbers. Hopefully there'll be a factor, but in this case I have memorized that 19 is prime. Our next problem, determine whether 28 is prime or composite. Now, since we memorized 19 was prime, is 28 prime? And all we got to do is prove that there's another factor besides 1 in itself. And all we got to do is use our divisibility rules that we've learned in our past lessons. And I can look in the ones place that 8 is even. That means it's divisible by 2. So 2 is a factor of 28, including 1 in itself. This is composite. And there you go, ladies and gentlemen. That's it. Alright, we're going to write the prime factorization of 36. We just learned about the definition, and in this lesson we're going to use a factor tree. So what we do is start with 36, and then using divisibility rules are your knowledge of factors of 36, such as 6 times 6. And then you break that down into two factors. I have 2 times 3, and since this is the same, 2 times 3. You can see now our factor tree has reached the bottom. Why? Because at the end of everything we have prime numbers. 2, 3, 2, 3. We like to write our answers in numerical order, so 2 times 2 times 3 times 3. And that's one way of writing the answer. Sometimes you'll see that we need to write our answers using exponents. And we notice that 2 repeats twice, so we'll use the exponent of 2. And we know that 3 repeats twice, that's the base, and we'll use 2. So either one of these are acceptable. Right now I suggest that you use this one right here, but this one works just as well. In this problem, we're going to factor each monomial, and this is a monomial because it's a constant, and we have variables all being multiplied together. What we need to do is factorize each one of these individually. Start with the 8. I do 2 times 4. I'm going to underline here that says that I should stop at a 2. That is a prime number. Then I'm going to factorize the 4, and that's 2 times 2. Next up, a. There are no exponents for a. It's just a to the first power, so there's only one a. Now I'll do b squared. And b squared with the base being b and the exponent being 2. That means that I have b being multiplied twice. Now I just need to put this all together in a coherent answer. Now we have just factorized our monomial 2 times 2 times 2 times a times b times b. And that is how we write the answer, making sure that we put a multiplication symbol in between, avoiding x but using the dot, or we could even use parentheses. On this slide, we also have factor each monomial. We now have a negative 30 times x cubed times y. And let's deal with the negative 30 first. The first step, and we kind of read this in our definition of factors, is that we needed to get rid of the negative 1. So negative 1 times 30. That's the first step. We removed the negative out and made it a negative 1. Now we're just going to use the factor tree to complete 30. So something has 2 times 15. You can see I continued on with 2 times 15. Underline the 2 because that's prime. Then I went to 15 and found 2 factors. I found 3 times 5. I underlined those so you can see that they are both prime numbers. Let's work on our variables next. You see that x cubed. The base is x. That means I take x 3 times, multiply them together. And of course, y to the first is by itself. There's no need to write anything else. Alright, now let's combine all 3 parts. We have the prime factorization of negative 30. Remembering to keep the negative 1. Times 2 times 3 times 5. Factorization of x cubed times x times x times x times y. Ladies and gentlemen, we have factored the monomial.